The next practice problem is titled Bone Mineral Mystery. Imagine you're working with Sofia Alvarez, a wildlife senior researcher studying calcium metabolism in lizards from a desert habitat. Because these lizards often lose calcium through their bones when their diet is low. We have a scenario here wherein she begins by obtaining bone ash from a specimen, then treats the ash so that calcium oxide reacts with carbon dioxide to form a solid compound calcium carbonate. Then she weighs it to estimate how much calcium was present in the bone originally. So let's discuss this each step. What's the purpose of each step in this method? So for step 1, which is collecting the bone ash from the specimen, this actually ensures that the mass measurements are meaningful for mineral content, so not confused by soft tissues or other organic material which can serve as interferences or can eventually affect your results. For example, so it says that bone ash analysis is a straightforward method for determination of mineral content of bone tissue. So we actually need to, for biological samples, we actually need to be specific with which part of the specimen are we analyzing. So removing the organic material, we isolate the mineral part, which actually represents or reflects how much calcium was stored in the bones. The next step is converting the bone ash into solid calcium compound and weighing it. This is important because in gravimetric analysis, it actually relies on converting an analyte into a compound with known composition and then measuring its mass so the original quantity of the analyte can be calculated. So here you can observe it's a different way of how we obtained our calcium carbonate. Let's see in the process. So in the continuation of our scenario, we have she processes a bone ash sample and converts it into solid compound calcium carbonate using gravimetric method. So here's what we got. We got the massive empty weighing crucible, so 12.45 grams, mass of crucible plus the collected calcium carbonate after drying, 32.90 grams. So our tasks are to identify the balance the chemical reaction, calculate the actual yield or the mass of the calcium carbonate collected in this experiment, determine the moles of calcium carbonate. So here we can actually see in the balanced chemical reaction that here the calcium carbonate is precipitated differently in comparison to our earlier example. So here we identify the reactants and products first. The reactants or the bone ash material that is treated calcium oxide and treated with a gas or the carbon dioxide gas. So probably we'll need an equipment for this or we'll need to control our environment in order for us to obtain our product, which is a solid compound recovered in the form of calcium carbonate, and it's in solid form. Here, it's the chemical equation is already balanced, so no further coefficients are added to the equation. And by the way, this is a combination reaction or a synthesis reaction because two reactants combine to form one product. So for task number 2, we are asked to calculate the actual yield or the mass of calcium carbonate collected in this experiment. To determine the mass of the product only, we will be using this formula wherein the mass of calcium carbonate is equals to the mass of the crucible plus the calcium carbonate or the precipitate. Pardon me, this is a minus, so minus the mass of empty crucible. So we substitute the given values in the formula and we obtain 32.90 grams minus 12.45 grams of our empty crucible. We obtain 20.45 grams. So if we have a different method for this, so we'll probably need to get the sample of our mass. But in this case, since it's a direct method of subjecting it to a gas carbon dioxide, so we can use this formula instead. So our actual yield as calcium carbonate collected is 20.45 grams. To determine the mass of calcium carbonate, we need to first find the number of moles of calcium carbonate and then divide it by the mass of calcium carbonate by the molar mass. So we need to get first the molar mass, which is here, it's calculated, and we divide the mass by the molar mass. So to get the molar mass of calcium carbonate, we'll need to get the atomic masses from the periodic table, and then it's the summation, or we add these. But first, you need to multiply it by how many atoms are present in your chemical formula of the calcium carbonate. So we can see here, so you have your calcium, carbon, and oxygen. And if we get the summation, it's 100.08 grams per mole. To get the moles of calcium carbonate, we need to divide the mass, which is 20.45 grams, divided by the molar mass of 100.08 grams per mole to obtain 0.2045 mole of our calcium carbonate. So that's your moles of calcium carbonate. An additional task for this is to calculate the moles of calcium. So for here, our solution is to base it on the chemical formula of the calcium carbonate. So we know that each mole of calcium carbonate contains 1 mole of calcium. So 1 mole of calcium. Therefore, the moles of calcium are equal to the moles of calcium carbonate, which is the ratio here is 1:1. 1 mole of calcium is equal to 1 mole of calcium carbonate. So we obtain moles of calcium is equals to 0.2045 moles. So just a further additional input on this, we can actually design our method with replicates. So we can use 3 replicates or 3 trials. So for this, so for example, you obtained per trial, so we use 3 replicates, and then you can get the mass of calcium carbonate here by using the same formula. We get the mass of empty crucible and mass of crucible plus calcium chloride. So in grams, these data are measured in grams. And in order to get your mass of calcium carbonate, you just use the formula wherein we subtract the mass of crucible from the mass of our crucible containing the calcium carbonate. So you can actually get, if you use the same sample and then replicate it, you actually can get the average mass of calcium carbonate. So in this case, we got 20.50 grams. And then using the standard deviation formula wherein we have the the data, or getting from the table, we get 20.45 minus the average or the mean, then we square it, and then we get the summation of these. So your data minus the mean, then square it, plus your other data minus the mean, and then we square it again. So we actually use the square root, and after you get this data here, so you need to divide it by your number of replicates, or probably trials, so minus 1. So in here, since we only use 3, so we minus it by 1. And I also have here the data for calculating the square deviation, or the standard deviation from the mean. So for reporting our data, this you actually report it by using the average, or our mean, which is 20.5 or 20.50. So we use plus or minus our standard deviation, which is 0.05 grams. So we actually report it as 20.50 plus or minus 0.05 grams. So this is the range wherein the values for the actual yield of, or the mass of calcium carbonate is actually, or it's within the desired value, which is still accurate and precise. So these are our references, and that's it for our lecture for today.